So good evening everyone. My name is Sahas. I'm a rising senior at Monte Vista High School, and this is my main project. It's an autonomous car. So here's a demo of it working, and I'll show you how it works while it's running. So it takes 5 seconds to calibrate the sensors, but the way it works is it takes a gyroscope that detects what direction the car is heading, and it measures how far the wheel is turned. So right now you can see it making a turn right where it's supposed to. And it follows down the ramp right outside. So the way it works is, as I mentioned earlier, it takes a gyroscope, tells me exactly what direction that the car is headed, and measures on the bottom. You can see it measures how far the wheel is turned, and using that I can create a vector starting from the original starting position to where it is now, and I use that to navigate. So I had a lot of problems coming up with this final product, mainly because it was a cheap $20 car from Target, and one of the main problems was it cut a lot of corners when it came to steering. So you can see the car in the video was wobbling. That's only because the wheels can only move fully left and fully right. There's no in between. So that's why I had to do something called bang-bang control, which means if I'm too far right, I move left, and it's simple like that. So another problem that I ran into was detecting how many times the wheel is turned. My original idea was to use something called an optocoupler. The way it works is it shoots an IR beam, and I can tell when it's blocked or unblocked as the wheel rotates. And using that I can show how far the wheel is turned. But the problem was I wasn't allowed to cut up the chassis originally. So I tried using an LDR, which senses light, and you can see the spokes on the wheel here, which I was trying to detect if it was behind the spoke or not. However, that was too slow because it involved charging and discharging a capacitor. So I tried using a voltage divider, but that was too inaccurate. So I eventually cut up the chassis. Another problem that I ran into was finding a way to drive the motors. Originally it came with a small logic board right here, and I was going to solder pins and control it that way, but that shorted out day one, and so I had to find a part that could supply some cheap Chinese motors that I couldn't find the data sheet anywhere, and I think those provided some very interesting challenges for me to overcome. Another final problem that I ran into was communication issues. The Raspberry Pi UART pins died, so I had to connect that to an Arduino on top and connect the Arduino to a Raspberry Pi. So I didn't take the easiest path through this car, and I think I learned a lot more that way. I took some $20 car, 0 to 60 and never, and I was able to make it follow my own path. So the way it works is I give it a map of its surroundings, I gave it a map of the ramp, and I gave it a point A and a point B, and it followed its own path through the obstacles, and it doesn't do course corrections, but it does optimize it for the way that the wheels can only move fully left or fully right. So I think I learned a lot more than if I take the straight path through it. I learned a lot about electrical engineering, circuit design. I learned about interrupts on the Raspberry Pi, and I even did some kernel processing for the interrupts. And overall, I think it was a great experience, and I really pushed the boundaries of what I already knew about robotics and Arduino into something that's very cool, and I'm very proud of.
So what are the potential use cases that you think?
You know, I haven't really thought that far. I was just doing it to see what I could do. I wanted to mess with autonomy, and I figured this was good. This would provide a bunch of challenges, especially that when you think about autonomy, the easiest way to do it is if you can move 45 degrees right off the bat. But this has wheels and a turning radius, so that became definitely harder. So I didn't do it to solve any problems. I sort of did it to just expand my understanding.
I had a question. So how does the map part work?
So I loaded up Microsoft Paint, and for every pixel on that image, it represents a square inch. So yeah, and then I feed that into something called an A-star algorithm, It's shortest path finding. It rates the pixels based on their likeliness to be used, and it finds that. Then I put that through another algorithm, which, because the A-star algorithm gives me 45 and 90-degree angles, so I find tangent arcs that allow me to traverse those angles, and that's how I.
Yeah, cool.